All right, if you're heading into a career in finance or accounting, you've probably been trained to see the world in straight lines. But let's be real, the real world is messy. It's curved. So today we're going to talk about the tool that's built for that messy reality, nonlinear programming. And trust me, this isn't just some abstract theory. It's the skill that can make the difference between a good decision and the best possible one.
Let me ask you a question, a really simple one. If you double your advertising budget, do you really expect to get double the customers? If you double the size of your factory, do you get exactly double the output? Of course not. The answer is almost always no. You eventually hit a point of diminishing returns. And that simple, universal truth, that's our doorway into nonlinear thinking.
And this slide lays out the difference perfectly. On the left, you've got linear programming. Everything is a nice, neat, predictable, straight line. But on the right, you have nonlinear programming, or NLP. It's designed for the curves, the bumps, the complexities of the real world. Its job isn't just to find an answer. Its job is to hunt for the absolute best one, which is usually hiding somewhere off that straight path.
So what's the tipping point? What's the thing that officially pushes a problem out of that simple, linear world and into this more complex, non-linear one?
Well, the formal definition says it's all about optimization, when your formulas aren't straight lines. Basically, if the thing you're trying to maximize, like profit, or a rule you have to follow, like a budget constraint, is represented by a curve, well, congratulations, you're now in the world of NLP.
And you know, the triggers for this are surprisingly common. The second you multiply two variables you're trying to solve for, like price times quantity to get revenue, boom, you've created a non-linear problem. Same thing happens with exponents, square roots, you name it. Think of these as the mathematical fingerprints of real-world complexity.
Okay, this is where it gets really important. Why should you, as a future financial analyst or accountant, actually care about this? Because this isn't just math. This is the engine running underneath some of the most critical financial models you will ever use.
I mean, NLP is everywhere, from designing engines to managing supply chains. But I want you to look at that very first point, optimizing financial portfolios. We're talking about the mathematical heart of modern portfolio theory, a cornerstone of finance. It's literally the how-to for building portfolios that give you the most return for a given amount of risk.
And here it is, in black and white. When you're trying to minimize the risk in a portfolio, you're working with variance. And mathematically, variance is a quadratic function. It involves variables that are squared. So what this really means is that one of the most fundamental jobs in all of finance is, by its very definition, a nonlinear programming problem. It's not optional. It's baked right in.
Now, all this might sound like you need a PhD in mathematics and a supercomputer to pull off, but you don't. In fact, you almost certainly have the tool you need on your computer right now.
That's right. The Humble Excel Solver add-in is an incredibly powerful and accessible tool for exactly this kind of work. It's designed to handle these messy, nonlinear problems, putting some seriously sophisticated optimization right at your fingertips. And using it is actually a pretty simple four-step dance. First, you tell Solver which cells it's allowed to change. Those are your variables. Second, you point it to the one single cell you want to either maximize or minimize. That's your objective. Third, you add in your rules, your constraints. And fourth, and this is the most important part for us, you tell it you're dealing with curves by picking the GRG nonlinear engine. That's it.
But there's a catch. Of course there's a catch. See, with nonlinear problems, getting an answer isn't the same as getting the best answer. There's a hidden trap you absolutely have to know about. So you set it all up. You click Solve, and Excel gives you an answer. It looks good, it follows all the rules, but how can you be sure it's the absolute best solution out there and not just, a pretty good one? This is the big idea right here, the difference between a local and a global optimum. Think of it like this. A local optimum is like being at the top of a small hill. From where you're standing, every direction is down, so you think you found the highest point. But the global optimum? That's Mount Everest. It's the highest peak in the entire mountain range. And it's really easy for a standard solver to get stuck on one of those little hills.
And here's the crazy part. The initial numbers you type into your cells before you even run Solver, your starting point, can completely change which hill the algorithm decides to climb. This means two analysts with the exact same model could get two totally different optimal answers just based on where they started.
So how do we find Mount Everest? How do we make sure we find the true peak? Well, Excel has a brilliant feature for this called Multi-Start.
You can think of it like sending out 100 different explorers to start climbing from 100 random spots all over the mountain range. Solver then runs the problem from every single starting point and just reports back the highest peak that any of them found. It's a game changer.
So, let's wrap this up. What do you need to remember? Number 1, the real financial world is curved, it's complex. Number 2, nonlinear programming is the tool we use to model that complexity. 3, you can get started with this today using Excel Solver. And maybe most importantly, number 4, always be skeptical of your first answer. Always ask yourself, is this just a local hill, or did I find the highest peak?
Just remember this. In any problem, there can be many local optima, lots of little hills, but there is only one global optimum. Your job as an analyst is to develop the skills and, frankly, the mindset to find it.
And there you have it, a look into nonlinear programming. With this tool, you're no longer stuck with just straight-line assumptions. You can start to model the world as it actually is. So the question I want to leave you with is this: what complex, real-world financial problem are you going to tackle first? Thanks for joining this explainer,